So hi guys, welcome back to the YouTube channel Unknown IITians. Hope so all you are doing great. In this lecture we will study about week 3 statistics. So let's begin. So the topics we would be covering for this lecture is what is numerical data, frequency table for numerical data, stem and leaf diagram, mean, median and mode, measures of dispersion, percentiles, quartiles and interquartile range, and box plot. Alright, so let's begin. So first of all, we have types of variable. So we have two types of variable. First is categorical variable and second is numerical variable. Numerical is divided into two parts, that is discrete and continuous. So what is numerical data? As the name suggests, it consists of numbers. It represents quantitative information and can be measured and counted. This data type is often used to perform mathematical operations and statistical analysis. So its main function is to perform mathematical operations and statistical analysis. All right. So now here we have frequency tables for numerical data. We have organizing numerical data. We have two types here, that is discrete variable and continuous variable. Discrete variable means single value and continuous variable means classes. All right. So it is the count of something and continuous it is the measurement of something. So here are some important new terms which you have to revise. All right. So the first one is lower class limit, the smallest value that could go in a class. Upper class limit, the largest value that could go in a class. Suppose we have a data and here classes are given, that is 20 to 30, 30 to 40, 40 to 50, 50 to 60, up to 80 to 90. All right. So here 20 is the lower class limit and 90 is the upper class limit. All right. Here the next is class width. So class width is the difference between the lower limit of the class and the lower limit of the next higher class. All right. So it is the difference between the lower limit and the lower limit of the next higher class. Then we have the class mark and it is the average of two class limits of the class. Alright. So here we have a class interval contains its left hand but not its right hand boundary points. Suppose we have the class 20 to 30 and 30 to 40 and 40 to 50. Alright. So here this 20 is included here. Okay, and here this 30 is not included, not included. All right, so here 30 is included and 40 is not included. Here 40 is included and 50 is not included. All right, so this is what the fifth point is trying to say. All right, so we will do it the same as the further up to the classes. All right, so now we have the example of discrete variables. So we have, suppose, a data set reports the number of people in a household. The following data is the response of 15 individuals. So the distinct value, the variable, the number of people in each household takes it 1, 2, 3, 4, 5. So we need to make frequency distribution table here. So for in the previous lecture I already told you how to make frequency distribution table. So now here we will count for 1. So we have 1 and 2. Now count 2. 1, 2 and 3. Now count 3. 1, 2, 3, 4 and 5. Now count 4. 1, 2, 3 and 4. And 5 we have 1. Alright, so here we have 15 frequencies. So now we will make the telegram here. 2, 3, 5, 4, 1. Alright, so now we will find relative frequency. So I already told you the formula of relative frequency in the previous class. So relative frequency is equal to the particular observation we are considering, alright, upon the total number of observation. So here it will be 2 upon 15, 3 upon 15, 5 upon 15, 4 upon 15 and 1 upon 15. Alright, 1 upon 15. So this would be 0.133. Alright, this would be 0.2. This will be 0.33. This will be 0.26. 66, and this will be 0.066. 0.066. Alright, so this is how you represent the frequency distribution table in the discrete variable. So now we have continuous variable. So we have an example here. We have the marks obtained by 50 students in a particular course. So here we will find out the frequency again, as I already told you in previous slides, that suppose this is the class, so here 30 will be included but 40 will not be included. All right, so according to this you have to fill out this frequency distribution table. So let's count for the 30 to 40 first. So 1, 2, 3. So we have 3 here. All right, 1, 2, 3. Okay, so now we will see for 40 to 50. Here 50 will be excluded. So 1, 2, 3, 4, 5 and 6. Okay, so here we have 6. 1, 2, 3, 4, 5 and 6. Now we will count for the 50 to 61. Here we will not count 60. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So we have 17 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. All right. So now let's move to the 60 to 70 class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So here it is also the same 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Now we will count from 70 to 80. So we have 1, 2, 3, 4. So we have 4 here. Okay, 1, 2, 3, 4. So now here we will count for 80 to 90. We have 2 remaining. So we will mark this. So we have total 49 frequency. Okay, so here the relative frequency will be 30 by 3 by 49. 6 by 49, 17 by 49, 17 by 49, 4 by 49, and 2 by 49. So we will find out these. So this is 0.061, this is 0.122, this is 0.346, 0.346, and this would be 0.081, and this would be 0.0408. So this is how you calculate the frequency distribution table for the continuous variable. All right, so now we have stem and leaf diagram. Here we have, it is also called the stem plot. Each observation is separated into two parts, namely a stem consisting of all but the rightmost digit, and a leaf the rightmost digit. Okay, so suppose we have 75, so we have stem here and we have leaf here. So the stem will be the left one digit, that is 7, and leaf will be the rightmost digit. All right, so suppose we have 14, 75, 68, and 78. So the first way is to put them in ascending order, that is 14, 68, 75, and 78. Then make a table, that is stem and leaf. So here 1, 4, 6, 8. Now 7 have there is a 7 common in two numbers, so we will write 7 and we will write one number here and second number after that. All right, so this is how you represent a leaf and stem diagram. So now we have a question here regarding the stem and leaf plot. So we have a table 4, 5, 6, 7, 8, and 9. So we have 1, 2, 7, 8, 5, 6, 0, 5, 8, 8, 8, 0, 0, and 5. So first of all, we will write it in normal. 41, 5 to 52, 57, 58, 65, 66, 70, 75, 78, 78, 78, 80, 80, and 95. All right. So here the first question says that how many entries are there? So we will count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here we have 14 data entries. Now we have to find the range. So range is equal to the maximum observation minus minimum observation. So here maximum is 95 and minimum is 41. So this would be 54. All right. Question third says list all the entries less than 60. So we have 4 entries here, that is 41, 52, 57, and 58. So 41, 52, 57, and 58. So this is how you solve the problems regarding stem and leaf plot. All right. So now we have the times in minutes taken to change some tires. We have to make a leaf and stem diagram for this. So first step is to arrange them in ascending order. So 5, 7, 8, 8, 10, 10, 10, 10, 12, 15, 15, 15, 16, 20, 20, 20, 24, 25, 33, and 35. So this is the ascending order of this data set. So now we will make a line right here, stem and leaf. All right, so now there are no left digits, so we will write them in leaf. So 5, 7, 8, 8. Here we have the left digit as 1, so we will write here 1, 0, 0, 0, 0, 2, 5, 5, 5, and 6. So here we have two common as the left hand digit 0, 0, 0, 4 and 5, and last we have 3, that is 33 and 35. So this is how you calculate the stem and leaf diagram. All right, so now we have descriptive measures. We have most commonly used descriptive measures, and they are categorized as measure of central tendency and measure of dispersion. So we have descriptive measures, and it is of two types, that is measure of central tendency and measure of dispersion. All right, so here, wait for a second. Ah. So these are the measures that include the most typical value and or the center of the data set, and measure of dispersion indicates the variability or the spread of the data set. So its main point is to indicate the most typical value or center of a data set, and here it indicates the variability or spread of a data set. All right, so now we have mean here. So mean is also called as the average, that is mean is equals to average, that is sum of all observations upon number of observations. So it is the most common used in the measure of central tendency. All right, so we have here two types of mean, that is population mean and sample mean. Population is denoted by capital N, and sample is denoted by small n. All right, so here population mean is nu is equals to n I equals to 1 xi by n, and here sample mean is equals to small n I equals to 1 xi upon small n. So here nu is denoted by population mean, and here these are the number of observation in population, and here small n is the number of observation in sample. All right, so here this is denoted by x, that is sample mean. All right, so now we have an example here, mean for the group data, discrete single value data. So here is the data given. We have 15 individuals responses. So here x, this is denoted as mean. Okay, so here this is denoted as the sample mean. So here we have the formula f1 x1 f1 x1 plus f2 x2 plus fn xn upon small n. All right, so here we have 1 as 3, 2 has a frequency of 3, 3 has a frequency of 4, 4 has a frequency of 4 and 5 has a frequency of 1. So here if we see, so here value is xi, value is xi. Here telemark, here frequency fi, and here fi xi. All right. So here we have 1, 2, 3, 4, and 5. Wait for a second. So here we have the values 1, 2, 3, 4, and 5. So this is 2, this is 3, this is 5, this is 4, and this is 1. So 2, 3, 5, 4, 1. So this is xi and this is fi. So we will multiply both of them. 2 into 1 is 2, 3 into 2 is 6, 3 into 5 is 15, 4 into 4 is 16, and 1 into 5 is 5. So if we add all of them, we get 44. So here the mean says that it is sigma small n I equals to 1 xi upon n. So here it means that sigma fi xi upon sigma, wait for a second, yeah, sigma xi sigma fi, sorry, sigma fi. All right, or you can simply say that sigma fi xi upon n. So this would be 44 upon 15, that is 2.93. So here the mean is 2.93. All right, so here now we have a mean for group data in continuous data. Here we make a extra column that is a midpoint. Midpoint is the average of the class limits. Suppose in the first one we have 30 to 40. So here the midpoint will be 30 plus 40 upon 2. So that is 70 upon 2. This would be 35. So here midpoint is 35. Similarly, we will have 40 to 50. So this would be 40 plus 50 upon 2. That is 90 upon 2, and which is 45. So here we have a difference of 10. Similarly, alright. So here we take class interval. We have telemark. We have frequency. I am simply denoting it with fi, and here that is mi, and here is fi and mi. All right, so here we have the class 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 80 to 90. Wait for a second. 70 to 80 and 80 to 90. All right, so here we have 3, 6, 18, 17, 4, and 2. Okay, so here we will make 3, 6, 18, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. 1, 2, 3, 4 and 1, 2. So here midpoint will be, I already told you how to find the midpoint. So here this is 35, 45, 55, 65, 75 and 85. Okay, so fi and into mi. So 3 into 35 is 105. 6 into 45, this will be 270. 18 into 55, this would be 990. 17 into 65, this would be 1105. 4 into 75, this would be 300. And 2 into 85, 2 into 85, that would be 170. Alright, so this is how you calculate FIMI. So now the average will be, or the mean will be, sum of the MI, FI, add. So here the average will be X sigma FI MI upon N. So here you can say that if we total all of them, you will get 2940 and total is 50. So this would be 58.80 and this is the answer. All right. So this is how you calculate the mean for the group data, continuous data. All right. So now we have the conditions, like if we add a constant, let yi equals to xi plus c, where c is a constant, then the mean will be the same plus constant. All right, so suppose I have it is asked in a question that an observation is added as 18, so this would be the mean. Okay, the mean of the x plus 18. So this is how you calculate while adding a constant. Similarly, for the multiplying a constant, we will multiply the mean with that constant. All right, so if 18 is added, so the mean will be the initial mean into 18. All right, so now we have mean. So the mean of the data set is the middle value of in the order list. Middle value in the order list. So here we have two cases. So median have two cases, that is odd and even. So here if it is odd, so that would be simple nth n plus 1th by 2 observation. And if this is the case of the even, so we have nth by 2th observation plus n by 2 plus 1th observation. All right, so now suppose I have a data set that is 27, 30, 35, 40 and 45. So now if someone asks me that what is the median, so we will count the number of terms. So here the number of terms is odd, so n is equals to odd here, so we will apply that 5 plus 1 upon 2, so that would be 3. All right, so third one is the median, so the median is 35 for this data set, for this data set. All right, so suppose now we have 16, 18, 20, 21, 22 and 24, 28, 35. Okay, so now we have to find the median. So here n is even. So this would be n plus n by 2th observation, that is 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 2 and 8 by 2 plus 1th observation. So this would be 4 and fifth observation will be the median. So here 1, 2, 3, 4. This and this will be the median for this data set. Alright. So the sample mean is sensitive to the outliers, whereas sample median is not sensitive to the outliers. This is important. You can get these type of questions in the test. Alright. So here we give some cases like adding a constant and multiplying a constant. So if we add a value, suppose we add 10, so the new median will be, so the new median will be the old median plus the constant added, that is 10. So you have to remind it. All right. Now we have multiplying a constant. So here if we multiply a constant, so it is same as the main one. So new median will be old median into the constant. Suppose 10 is multiplied, 10 is multiplied, and here 10 is added. All right. So you have to keep them in mind. So now we have mode here. So mode is the of the data set is the most frequently occurring values. Most frequently occurring values. So if we add a constant to the mode, so here new mode will be equal to old mode plus the constant. So that is if 5 is added, suppose. So here the new mode will be equal to old mode plus 5. Similarly, if a constant is multiplied, suppose 5 is multiplied. So the new mode will be old mode into 5. Okay, so you have to keep them in mind. All right. So now we have measures of dispersion. So to describe that difference quantitatively, we use a descriptive measure that indicates the amount of variation or spread in a dataset. So, such descriptive measures are referred to as measure of dispersion, measure of variation, or measure of spread. In this course, we will be discussing about the following measure of dispersion, that is range, variance, standard deviation, and interquartile range. So, range is maximum minus minimum. All right. I already told you. So here this is important that it is sensitive to outliers. Variance. So population variance, population variance is denoted by sigma square, and sample variance is denoted by S square. So here the sample variation is the observation minus the population mean. Okay, so here nu is the population mean, and xi, x2 upon up to xn are the observation given. And here we will take the difference and then square and divide it by the total number of items in population, number of items in population. All right. Now for the sample variance, we have s square, and here x1 minus the sample mean. So x here is the sample mean, and the x1 x2 again are the observation given, and here n minus 1. Here n is the number of items in sample. Students make mistake in these that they here divide simply by capital N, but and here also they simply divided by small n. So you have to see it carefully that it is n minus 1, not simple small n. All right, you need to take care of this point. So now we have adding a constant. If we add a constant to the to the variance, so new variance have no change, that is simply will be equal to the old variance. All right, and new variance, if we multiply a constant, then suppose we multiply 5 with the variance, so the new variance will be equal to c square into old variance, that is 5 square into old variance. All right, so now we have standard deviation here. It is just the square root of the variance. If you see here that it is the same formula given, but this is not square, this is root there. All right, so this is applying the same formula, just it is making to the square root. All right, so which is the square root of the sample variance is the sample standard deviation. So if we add a constant to the new standard deviation, so there will be no change, no change. And here if we multiply, so it would be new variance equals to c square into old variance. All right, you have to remind this thing, this is important. So now we have percentiles, quartiles, and interquartiles range. So percentiles here, here the formula of percentile is NP. Here n is equal to the total number of observation, and p is equals to percentile by 100. All right. So now we have an example here that given the data set 1, 2, 3, 6, 9, 11, 45, 102, calculate the percentile rank for 18. So here we have a data set. We have 1, 2, 3, 6, 9, 11, 45 and 102, and we have to make the percentile for this. So we will simply calculate the percentile rank is equal to number of values number of values less than the observation upon total number of observation into 100. So suppose here before 11 we have 5 observations, so this would be 5 upon total number of observation is 8 into 100, so this would be 62.5 percentile. All right. So this is how you calculate the percentile rank. So now we have the question for the data set below. Find the percentile rank for a score of 33 and a score of 67. Also find the corresponding values to the 20th and the 45th percentile. So this is the data set given to us. So the first step arranged in ascending order. All right. So the ascending order for this will be 7, 17, 24, 25, 32, 33, 36, 46, 51, 54, 58, 59, 60, 60, 64, 67, 67, 70, 74, and 95. All right. So here n n is 20 here. N is the total number of observation. All right. So here percentile rank for 33, that is, so 33 here is the sixth observation. So before that we have 5 more observations. So this would be 5 upon 20 into 100. So as I have told earlier that percentile rank is equals to number of values before the observation upon total number of observation into 100. So you can just make a before the observation. All right, so you don't get confused. So after solving this would be 4 and this would be 25. So this would be 25th percentile. All right, now we will calculate it for the percentile rank. I'm denoting with PR for 67. So here 67th is 16th observation. So 16th observation, before that we have 15 number of observation left. So 15 upon 20 into 100. So this would be 5 and this would be 75th percentile. All right. So this much question is done. So now also find the corresponding values to the 20th observation and 45th observation. So now we have to find out the values. So index is equals to p upon 100 into n. So n is p is percentile here. P is percentile. N is total number of observation. All right. So here for the 20th percentile, this would be 20 upon 100 into 20. So this would be 4. All right, fourth observation. Fourth observation is 1, 2, 3, 4. So this is 25. Similarly, if we find for the 45th percentile, so this would be equal to 45 upon 100 into 20. So this would be equal to 9. So ninth observation. So ninth observation is 1, 2, 3, 4, 5, 6, 7, 8, 9. 51. So this is how you calculate the percentage rank and the corresponding values if we are given the percentiles. All right. So now we have the quartiles. We have 3 types of quartiles. first quartile, second quartile, and third quartile. That is 25th quartile. 25th quartile is equal to the first quartile, 50th quartile is equal to the second quartile, and 75th quartile is equal to the third quartile. So first is lower, second is median, and third is upper. So 5 number summary is, we have suppose 5 numbers. So that is, we have minimum, 20th percentile, 50th percentile, 75th percentile, and maximum. All right. So first quartile is written as Q1, second quartile is written as Q2, and third third quartile is written as Q3. This is lower, median, and upper. So if someone asks that what is interquartile range, so interquartile range is equal to Q3 minus Q1. It is also denoted by IQR. So this is upper minus lower. All right. Hope you all get it. Now we have the box plot, the same which it is telling us through the 5 number summary. So we have minimum, maximum at the end, and the starting point. Here we have a box, or where the numbers are plotted. The starting of the box is Q1, that is lower, middle is median, and Q3 is upper. Alright, hope you all understood it. Alright, so this was all about the week 3 statistics. Hope you all enjoyed the lecture. If you have any doubts, just comment in the comment section below. Thank you so much.